Good morning everyone. Today we will study about lesson 1 physics, electric charges and field. Electric charges and field. Let's see the contents of the chapter, all that we will read about. What we will read? The objectives of the lesson or the contents. First we will read the introduction. Then we'll read electric charges. Then conductors and insulators, charging by conduction, properties of charge, Coulomb's law, the vital law of this chapter. Then forces between multiple charges, the forces between multiple charges, electric field lines, electric flux, electric dipole in a uniform external field, the dipole in a uniform external field. Then continuous charge distribution, the continuous charge distribution. Then we'll read about Gauss law, and finally the formula chart of the chapter. So these are all the contents of the chapter we will go through. So it's all here: introduction, electric charges, conductors and insulators, charging by induction, properties of charge, Coulomb's law, forces between multiple charges, electric field, electrical field lines, electric flux, electric dipole in uniform external field, continuous charge distribution, Gauss law and formula chart. Then in introduction, the first thing, study of electrical charges. Electrostatics. It is the branch electrostatics. The study of electric charges are known as electrostatics. Electro means a word related to electrical things like electric charge, electric flux, electrical wire, all those. And static means rest, means charge at rest. The charge bit doesn't move. Then we will read about Coulomb's law and superposition principle in this chapter. We will read about electrical dipole, because we will deal with atoms. And its influences. Then we'll read about Gauss law. Various application is done of Gauss law. This is all about introduction. So first part, introduction, is over. Now we'll go to the second part, that is electric charges. Then now we will read about electrical charges. Electrical charges. These are of two types. One is positive and the other one is negative. How do we name them? Positive and negative. The scientist Benjamin Franklin named them positive and negative. Now let's see an example. Here is a glass rod and here the silk. When the glass rod is rubbed with silk by the conduction or induction method, we can do it by both the methods. We'll read about it later. Well, normally let's see for now. Glass rod and silk. When the glass rod is rubbed with silk by friction, the normal common method which you are familiar with, friction, the electrons transfer from glass rod to silk. The electrons, here it carries electrons, and those electrons are carried to silk. Electrons are carried to silk. So glass rod acquires positive charge and silk negative charge. So it becomes like this. Glass rod positively charged, it acquires positive charge, and silk acquires the negative charge. So here the positive charge and the negative charge, unlike charges, attract each other, and the like charges are at the farther end. So like charges repel each other, therefore like charges repel and unlike charges attract. And this is known as the fundamental law of electrostatics. fundamental law of electrostatics. Okay, the fundamental law of electrostatics. Like charges repel each other and like charges attract each other. Now let's see what is polarity of charges. Property which differentiates the positive and negative charge is known as polarity. It is known as polarity. The property which differentiates the two kinds of charges, the positive and the negative charge, that is known as polarity. If an object possesses an electric charge, then it is known as electrified or charged body. When the net charge is suppose 2 plus and 2 minus, then net charge 0. It will cancel out. Net charge 0. So neutral body. Neutrally charged body. If only positive or only negative, then a electrified or a charged body. Okay, positively charged body, negatively charged body. Here positively charged body means deficiency of electrons. Here negatively charged body means full of electrons. So here deficiency of electrons and here electron rich. So body full of electrons, body full of protons or positively charged. And neutrally charged body, the net charge is 0 if both plus and minus are equally distributed throughout the body. And the property which differentiates the positive and negative charge is known as polarity. So now a question comes. A body X has plus 2 coulomb of charge and a body Y has minus 2 coulomb of charge. So can we say that X has more charge than Y? Answer me. I will do the solution, but say me first. It's a statement like answer we have here and statement question also. Just say me. Body X has plus 2 and body Y has minus 2 charge. So which has more charge? Can we say that X has more charge than Y? Yes or no? I am giving you 2 seconds. Just say me answer. Comment below what you had answered. Now the solution is X has plus 2 coulomb charge, Y has minus 2 coulomb of charge. Just now I said you, if a body has both the charges equally distributed, then what is it? A neutrally charged body. Means it acquires both positive and negative charge. So the net charge is 0. So here also plus 2 and minus 2 will cancel each other. Right? Plus 2 and minus 2 will cancel each other. So net charge is 0. Both have same charges, equally distributed. So neutral body. Neither X is greater than Y nor X is less than Y. And vice versa. Answer is X is equal to Y. Okay. Now a question I am giving you. You try it up. Okay. Now the next question for you is, a body has positive charge on it. If a body has positive charge on it, then does it mean it has gained some protons or lost electrons? Say me. Does it mean it has gained some protons or lost electrons? Just a simple one word answer I am giving you. Time, do it. The answer that you gave me, please write on the comments so that I can see it, the way you are getting my points and understanding it. So now let's do it. If a body has positively charged, positive charge distributed throughout it, does it mean it has gained some protons or lost some electrons? Let's see what happens if we have gained some protons. Gained some protons means acquired some protons. Positive charge. It means gained some protons. Some word is here. Some word means that we have gained some protons, means there are also some electrons. Okay, some protons, some electrons. And here our question is, a body has positive charge and another body, it's saying, has lost electrons. Here it is not using the word some or lost electrons. Lost electrons means it has acquired positively charged. So which is similar? Which is similar? Option A or these two are similar. So this is the right answer. So lost electrons is the right answer. Then does it mean it has gained some protons or lost electrons? It has lost electrons. I hope you are clear with it. Now some more are left of electric charges. Now let's see about it. Then, as we know, matter is made up of the matter is made up of atoms and molecules. When we say body is charged, then either because of excess or loss of electron. Then in solids, electrons are loosely bound in atom. So it transfers from one body to another. A body can be positive by losing electron or negatively charged by gaining electron. Now, a apparatus to detect the charge on body. This is known as a gold leaf electroscope. This is known as gold leaf electroscope. Apparatus to detect charge on body. Gold leaf electroscope. Here the negatively charged body strikes here. Here it becomes negative and the charge flows through the gold leaves. As this becomes negatively and this becomes positively charged, so because of repulsion the leaves diverge more. Okay, in this way it happens. So it is gold leaf electroscope, apparatus to detect the charge on body, and the diversion of the leaves is an indicator of amount of charge. It is an indicator of amount of charge. So the topic of electric charges is over. Now we'll go to the next content. Now before we shift to conductors and insulators, now let's see two questions. What will happen to leaves of electroscope if a positive charged body is brought near an uncharged electroscope, positive charged electroscope and negative charged electroscope? Answer it. Please think before you answer. What will happen to leaves of electroscope if a positive charged body is brought near an uncharged? First think that what will happen to the leaves of electroscope if positive charged body is brought near an uncharged electroscope. Suppose the electroscope is uncharged but a positive charged body is coming in contact with the uncharged neutral electroscope. So what will happen? Suppose this is the electroscope. Think, this is the electroscope. A positive charged body is coming in contact with it. The positive charge, this is uncharged, it is neutral. It means it will have positive and negative charge. The leaf will diverge more. Why will it diverge more? Because of here the plate is there na. Wait a minute. Just wait a minute. Here a plate is there. So here some positive and negative charge as neutral charge was there here. So it has positive and the positive charge will go from to some this side and some, because attraction will happen. Let me show you on the next diagram. This is positively charged. Again here as attraction will occur between positive and negative charge, so negative will stay here. And the positive charge will pass through the leaves. Here positive charge, here positive charge. So repulsion, more diversion. So in case of uncharged electroscope, the leaves will diverge. In the same way, you carry on with positive charge electroscope, negative charge. In positive charge electroscope, it will more diverge. It will diverge more, because if here it is positively charged, then repulsion will occur. Huge repulsion, because here also positive, here also fully positive. So because of repulsion, some positive will come here, and here also positive, here also positive. It's repulsion, the leaves repulsion, so it will diverge more. So here more diversion, right? More diversion. Then what will happen if negative charge electroscope is there? First converge, then diverge. Either it first may converge, then again may diverge. First converge is sure, but the next time it may diverge or may converge further in case of negative charge electroscope. So I hope you got it, and if you don't understand, then please do write in the comments so I can explain it further. Then what happens, the next question is, when a negative charged rod is brought near the cap of gold. It is brought near the cap of gold leaf cap electroscope, where in whose case it is earth. I hope you wouldn't have understood the question. Let me make you understand. If a negative charged rod is brought near the cap of gold leaf, means here near the cap of gold leaf means this is the gold cap. If it is brought near the cap of gold leaf electroscope, in whose case will it get earth? Leaves will have induced positive charge, or positive charge is induced on one leaf and negative on the other leaf. Option C is no charge is induced on the leaves, or the leaf has negative induced charge fully. Same, leaves will have induced positive charge fully, or one end induced, one end positively induced, one end negatively induced, or no charge is induced, or wholly negatively induced. When a negative charged rod is brought near the cap of gold leaf electroscope, in whose case it is earthed. Normal thing, just a common sense question. You can get it if you think it a bit deeper. Think. Answer is option D. The leaf has negative induced charge wholly. If you don't get how it is being, then please do write in the comments so I can explain you again. I didn't explain you this one because I already gave you the basic concepts and there is nothing else left. So this question you would be easily doing. If I solve everything, then you will just say yes and you will go on understand, and you won't be able to do from yourself. So this question also I made you understand. I hope you would have understood this. If you don't understand, then please repeat the video and see it again and again. And if you again don't get it, then please do write in the comment so that I can explain you again or further. Now let's shift to, we did some questions of some basic conceptual questions. Now let's go to conductors and insulators. Just a small part is given of it, then we'll shift to charging by induction. In conductors and insulators, the substances which allow passage of electricity easily through them are conductors. They have free electrons, and examples are metals, humans, etc. The substances where passage of electricity is not possible easily, that is known as insulators. No free electrons, example glass, wood, etc. Now there is a category of these both. The substances in which electricity is passed partially. The substances in which electricity is passed partially is known as semiconductor. The intermediate of conductor and insulator. Now, the process of sharing current to pass to ground through connecting conductors such as our body. The process of sharing charges with earth. Process of sharing charges with earth is known as the process of sharing charges with earth is known as earthing or grounding. Earthing or grounding. The process of sharing charges with earth is known as earthing or grounding. It is necessarily a safety measure for electrical circuits and appliances. Then let's read about three types of wiring: live wiring, neutral wiring, earth wiring. The live and neutral wiring carries electric current from power station, and that electric current which is carried from the power station is connected to the metallic plate, buried metallic plate, and that is connecting to our houses. Earth wire connects to metallic plates. And if due to some fault live wire touches the metallic body, high amount of accumulated charge on metallic body flows to earth without damaging the appliance and without giving the shock to us. If by some fault live wire touches the accumulated charge of the metallic body, high amount of accumulated charge on metallic body flows, but because of earth wire it without damaging the appliance and giving shock to us, doesn't give shock to us. Then now we'll see about charging by induction. Now let's see about charging by induction. See, this is a positively charged body. This is a positively charged body. This is a negatively charged body. And if this negatively charged body and positively charged body, these are unlike charges, so in the next step that come closer, they attract each other. They do not touch, see the difference gap, but they come closer and attract each other. Now the next case, positively charged body, neutral body. In this case the positive charged body will attract its negative charge, so the like charges repel each other, so the like charges are produced at the farther end and opposite charge produced at the near end, and farther end like charges. So this is the method of induction. When a positively charged body or a charged body, so in these two cases you will know that a charged body attracts a neutral body, a charged body attracts a negatively charged body. Charged body attracts unlike charges, charged body attracts neutral body. In case of induction, when the neutral body is kept in touch with a positively charged body or with a charged body, the same charges are produced at the farther end and unlike charges are produced at the near end, and the same charges are produced at the farther end. So this is the process of induction. Alright, and note another point, that repulsion is a shear test. Repulsion is a shear test for a charged body. So that's all for today. Thank you. I hope you will like this video, and if any doubt arises, please to mention in the comment box. In the next video we will start from basic properties of electric charges. In this video we read about electric charges, conductors, insulators, and the introduction and the charging by induction process. Next video we will learn about basic properties of electric charges. Thank you for watching this video. Thank you for watching this video, and I hope you would have at least gained something. So keep working hard.